Hello everyone. Today we are going to discuss about a topic called pointers. In this session, topics to be covered are what is a pointer, why we need a pointer, initialization of a pointer, declaration and their types, disadvantages, and we are going to see a topic called pointer inside a pointer and some programs based on these pointers. Now let me see what is a pointer and its definition. Pointer is nothing but a variable which stores the memory address of another variable. And let me see a small example based on these pointers. Now let me see a general example based on the pointers. Pointer is a variable which stores the memory address of another variable. Now let me consider one variable n which stores the value of 5 and which has the memory address of, let me consider 1024, which is the memory address of variable n. And now let me consider a pointer variable ptr. What does this ptr do? Which stores the memory address of the variable n, that is 1024. Before going to the initialization and declaration, let me see why we need the pointers. Consider it has both advantages and applications. Reasons why we need the pointers are efficient memory management, dynamic memory allocation, manipulation of data structures, array manipulation, and direct memory access. Efficient memory management, it means optimizing the memory used for better performance. And dynamic allocation, allotting memory at runtime. And data structure manipulations, modifying the elements in a list, like inserting into a linked list. And array manipulation, finding the maximum value in an array and iterating through tracking the largest value. Direct memory access, it means copying a data from an hard disk to RAM without the CPU involvement. These are the reasons why we need the pointers, and we can consider this as an applications and the advantages also. Suppose think that if we don't have pointers, how can we access the memory address? Now we can use arrays for the accessing the memory address. Can access and do same function using arrays by indirectly accessing the array indexing. Let me suppose consider a small example. As we can access the memory address by using arrays, let me consider one general example. Let me take an array with an elements of size 5 and the elements are 1, 2, 3, 4, 5. And we know that let me give an index of 0, 1, 2, 3, 4. Now let me access the array by using their indexing. We are accessing the memory address indirectly by using the index. Now let me consider int value is equals to array of 2. Int value is equals to array of 2. By using array indexing, as the result we pointed to the output value, that is 3. But if we use the arrays instead of pointers, there are some drawbacks. Let me see what are the drawbacks of the arrays in the way of pointers. Now the drawbacks of arrays are fixed size, memory wastage, no direct memory access, insufficient resizing, and the limited versatility. Now here we need to look into one point that without pointer we cannot access the dynamic memory allocation in C language. This is the main drawback of arrays in the way of pointers. Now let me see the initialization and the declaration of an pointers. Now let me see the declaration of an pointer. Let me see the general syntax for declaration of an pointer, that is data type star pointer variable. Let me see how exactly the syntax of declaration of a pointer will work. This is the data type which refers to the type of value that pointer refers to. And next, this one is the star, which refers to the value at particular memory address. Next, this one is the pointer variable. This pointer variable may be a variable. It may be a variable. Now let me see example for the syntax for a pointer. That is, let we consider the data type, that is int star. Let we consider the pointer variable as ptr. This is pointer to the integer. Now we can see the another data type, that is character. That is pointer to the character. And next one is the float. Next, pointer to the floating point, that is decimal point. This is how exactly the declaration of a pointer works, in which the syntax was data type star pointer variable. The data type may be any data type, that int, character, float, and next one is the star, which gives the value at a particular memory address. And next one is the pointer variable. It may be any random variable which point towards the value of any pointer. Now let me see the initialization of a pointer. The general syntax for the initialization of a pointer is data type star pointer name pointer variable is equal to ampersand of variable. Data type, it can be any integer, float, or the character. And next one is the pointer variable, and next one is the variable. It is the ampersand of variable. It means address of operator followed by the variable whose address is assigned to the operator. We can declare it explicitly also. Let me see one example how exactly it works. That is int star. Let me take pointer variable as an ptr, that is equals to ampersand. Let me consider the variable as I. Let me see one small example. Let me consider before initialization we need to declare a pointer. We already know the general syntax for the declaration of a pointer, that is data type. Let me consider the data type as an int star. Next one is the pointer variable. Let me consider the pointer variable as ptr. Then we need to declare a variable which need to find the memory address of that particular variable. Next we need one variable, so let me declare int I as a variable. And now let me initialize the pointer, that is ptr is equals to ampersand of I. This is how exactly we can explicitly declare an initialization of a pointer. Or else we can declare directly a pointer like int star ptr is equal to ampersand of int I. Now let me see one example. Let me consider a variable I which stores the value of 3 with the memory address of 1024. Now we declared a variable which stores the value of 3 and the memory address of 1024, and again we declared a pointer variable. Now pointer variable, that is ptr, which has the memory address of 1036. Let me consider it. Now what does it will do? What does ampersand of I? It means the address of the I variable, that is 1024, will be stored in the pointer variable. This 1024 will be stored in the pointer variable, that is 1024. This is how exactly works, that is ptr is equals to ampersand I. The pointer variable and this one is the variable. The address of the variable will be stored in the pointer variable. This is how exactly we can initialize the pointer. Let me see most commonly used pointers in the C language. There are two types. First one is the null pointer. Other one is the void pointer. Still there are so many pointers, so many types. So the most commonly used are these two. One is the null pointer, another one is the void pointer. Null pointer, it means it is a special pointer in many programming languages. What it does, it means it will not point to any memory locations. Hence it will typically represent the constant value null or a null pointer. Let us see the syntax of it, that is int star pointer variable is equals to null. It represents that it will not point to any memory location. The advantages of the null pointer is, the main advantages of the null pointer is it restricts the garbage collection. A null pointer in the garbage collection, a variable no longer points to any valid data or often occurring after the garbage collector frees the memory of an object, leaves the pointer with a null value. This is the main advantages of null pointer. Now let us see the void pointer. It is a special type of pointer that can point to any objects of any data type. It means it can point to any data type, and the general syntax of it is void star generic pointer. This is the general syntax. By using it, we can point to any data type. These are the most commonly used two types of pointer. Now let us see the disadvantages of pointers. If we use the pointers, what are the disadvantages? We will get to know. The disadvantages of the pointers are dangling pointers, memory leaks, null pointers, difficulty in debugging, and the security risk. Dangling pointers. This is the most disadvantage of the pointer. It means the unused pointers pointing to non-existent memory, causing the unpredictable in the program behavior. And next one is the memory leaks. Failure to allot the free memory, leading it may consume the resources more. And next one is the null pointer. Pointers without valid memory address, causing crashes when they are accessed. And the other thing is, if a pointer is not initialized to a null or any other argument value, it is likely access an area of memory that is out of range of our program, or it may contain a pointer reference to argument object, and it may lead to the serious errors. And next one is the difficulty in debugging. Difficulty in the pointers make it challenging and requires more specialized tools. And next one is the security risks. Improper pointer use can lead to the vulnerabilities like buffer overflows. Due to the direct access of memory address, it is insecure. That's the reason why the pointers are not used in Java. That is the one of the reason. And these are the disadvantages of the pointers. Now let me see the another topic, pointers inside a pointer. It is also known as a double pointer. It is nothing but it is a variable which stores the memory address of another variable. This is nothing but pointers inside a pointer or a double pointer. Now let me see the general syntax of pointer inside a pointer, that is data type, double pointer, star star, double pointer. It can be a variable. Suppose if it is a pointer inside a pointer and that pointer inside a pointer, then it is a triple pointer. Then the general syntax of triple pointer is data type. Will use 3 stars. Next, pointer variable. This is double pointer or pointer variable. Now let me see a small example of pointers inside a pointer. Now suppose we have a variable of called I, which stores the value 3 and it has a memory address of, suppose let me consider 1024. It is the memory address of variable I. Now let me take a pointer variable, that is ptr of 1, which has memory address 1036, which is the memory address of pointer 1. Pointer 1. Now if we access it like int star ptr1 is equals to ampersand I. Now it will store the memory address of variable I. Now what is pointer inside a pointer? We need to declare it 2 pointers. It means a double pointer. If we declare another pointer called ptr2, which has a memory address of 1038, which is the memory address of pointer 2. This is ptr2. Let me consider it. Now if we access it, that is int double star. Why? Because we are accessing another pointer. We are storing the memory address of another pointer. So we are using the double pointer of ptr2 is equals to ampersand ptr1. Now what it will do is, the memory address of pointer 1 will be stored in the value of pointer 2. This is how pointer inside a pointer works. Now let me see some programs based on the pointers and let me continue the topic.
So, hello there, myself Vinant from IC department. So, in the previous part of the video, we saw the theory related to the pointers, such as what is a pointer, declaration of a pointer, initialization of a pointer, and some of the basic operations that can be performed on the pointers. And we also saw about a concept called pointers to array. Right. So, in this part of the video, we're gonna see how we can actually implement the pointers with the help of a programming example. So to start with, we have ash include stdio.h, that is standard input output dot header, which is actually responsible for our printf and the scanf functions. And then we have main function. So we all know that our program starts to execute from main function, right? And now coming to the declaration part of the pointer. So as we saw in the previous part of the video, the syntax for the declaration of the pointer goes by the data type of the pointer followed by an asterisk or a star, and then the name of the pointer variable. In our case it is ptr. So that That is what the declaration of the pointer. And the main thing to notice over here is the data type of the pointer. In this case, we have integer. So the concept is the data type of the pointer variable. It always depends upon the data type of the value at which it is pointing at. Suppose our pointer variable is pointing at integer value, then the data type of the pointer should be integer. And if it is pointing at float or a floating value, then the data type of the pointer should be a float. To understand this, we have taken a variable a which is of type int, and it is having a value assigned as 10. And now suppose if you want to store the address of this a to the pointer variable, then our data type of the pointer variable, that is ptr, should match with the data type at which it is, or the data type of the value at which it is pointing at. In our case, the value is of type integer, so the data type of the pointer should also be integer. So that's all about the declaration of the pointers. It is not enough that we just declare a pointer, we have to initialize the pointer as well. So now what is the initialization of the pointer? Initialization of the pointer is nothing but assigning the address of one variable or any variable to the pointer variable. So we shall understand it with an example over here. So we have taken a variable a which is of type int, and a value 10 is stored in it. So now let's say we have to assign the address of a to the pointer variable. So now how can we do that? So that can be done with the help of address operator, or it is also called as ampersand operator. So it is used to assign the address of one variable to the pointer variable. So that's the initialization of the pointer. And we can also print a pointer with the help of printf function. So let's see how we can do that. Printf %x. So we are using our format specifier as %x because we need our memory representation to be printed in the hexadecimal format. So followed by comma and ptr. And one thing to be noticed here is if we just type as ptr, then we are actually referring to the value that is stored in the ptr. So we know that the value that is stored in the ptr is nothing but the address of a. So let us save and run this code. So yeah, in the terminal we can see that we have got the address that has been stored in the pointer variable. Now let's say we want to print the value at which our pointer is pointing at. So for that we want to do the dereferencing of the pointer. So how we can do that? We can just add a asterisk mark on the pointer variable and change the format specified to %d. We are changing our format specified to %d because we are actually referring to a value which is of type integer, that is 10 in our case. So now let's save and run the program. So yeah, as we can see in the terminal, the value 10 has been printed.
In this part of the video, we're going to see the basic operations that can be performed and the pointers.
Print the pointer.
So to start with,
So in
we
the
have arithmetic
next section of the
operations.
video, we shall see how
So
we
as we
can
know,
perform
arithmetic
some of the
operations
basic
involves
operations
addition,
of the
subtraction,
pointer.
multiplication, and division. And these can be performed
So
using
in this part of the video,
pointers.
we're going to see
So let us
the
see
basic operations
with an
that can
example
be
that how we
performed
can do
on
that.
the pointers.
So for that, I have
So to
declared a
start with,
variable
we
a,
have arithmetic
which
operations.
is of type int,
So
and I
as
have
we know,
assigned a
arithmetic
value 10
operations
for it.
involves
And then I
addition,
have declared another
subtraction,
variable b,
multiplication, and division,
which is of type
and these
int,
can be
and
performed
I have
using
initialized
pointers.
the value
So
20
let us
for
see
b.
with an
And then
example that how we can do that.
And then I have
So for that, I have
declared
declared a
two
variable a,
pointer variables.
which is of
One
type
is
int, and I have
pointer
assigned
p,
a
and
value
another one
10
is
for
pointer
it.
pb.
And then I have declared another variable
And then
b,
I have assigned the
which is
address
of
of
type
a
int,
to the
and I
pointer
have
pa,
initialized
and
the
address
value
of b to
20
the
for
pointer
b.
pb.
And then we are
Now coming to
and then I
the
have
operation
declared
part,
two pointer
let us start
variables.
with the
One
addition
is
operation.
pointer p and another
For
one is
that,
pointer
I'm going to
pb.
declare another variable
And then I
of
have
type
assigned
int
the address of
named as
a
x,
to
so that
the
I can
pointer
store the
pa
result in that.
and address of b to the
So
pointer
now when we
pb.
say asterisk of
Now
pa,
coming to the operation part,
so we are
let us
actually
start with the
referring to
addition
the
operation.
first value,
For
or
that,
we
I'm
are
going to
we are
declare
actually
another
pointing
variable,
to the
of type int
value A,
named
that
as
is
x
10,
so that I can store the
followed
result
by
in
the
that.
operator, that
So
is
now when we
addition
say
or plus,
asterisk of PA,
and then asterisk of PB.
so we are actually
So
referring to
when
the
we say
first value,
asterisk of PB,
or
we are actually pointing to the
the
value B, that is
value A,
20.
that is 10,
So that's how we can
followed by the
perform
operator, that
operation
is
between the
addition or
2 pointers.
plus,
It is same
and
for
then
all
asterisk
other
of PB.
operations.
So
It can
when we
be
say
for
asterisk of
subtraction,
PB, we are
division,
actually pointing to
or for
the
the multiplication.
value B, that is
So now
20.
coming to the
So that's how we
printing
can
part,
perform
we can
operation
print it
between the
as
2
percentage
pointers.
D
It is same for
plus
all other operations.
uh,
It can be for subtraction,
percentage
division,
D.
or for
So
the
the first
multiplication.
percentage D is for the
So
first
now
pointer,
coming
that
to
is
the
PM, and the
printing
second
part,
percentage D is for the second pointer, that
we
is
can print it
PB.
as percentage
The
D
third
plus
percentage D, that is for the resultant, that is for
percentage
variable
D.
X.
So the first percentage D is for the first pointer, that is PM, and the second percentage D is for the second pointer, that is PB. The third percentage D,
asterisk of
that is for
PA,
the resultant, that is for
asterisk
variable
of
X.
PB, X. So now let us run this code and see what we gonna get.
Comma, asterisk of PA,
so yeah,
comma,
10 plus 20 equals to
PB,
30.
comma, X.
So that's how we
So now
perform
let us
arithmetic
run this
operations
code
of the
and see what we
pointers,
gonna
or
get.
with the help of the pointers.
So yeah, 10 plus 20 equals to 30. So that's how we perform arithmetic operations on the pointers, or with the help of the pointers. So now we shall see the last operation of the pointer, that is copying the value of the one pointer to the another. So let's see that with our example. So we have declared a variable in A and assigned a value 10 for it, and then we have declared two pointers. One is pointer PA and another one is pointer PB. Now we are assigning the address of A to the pointer PA, and then we are copying the value of PA to the PB. So which means now both the pointers PA and PB are pointing to the same value A, or the value 10. So now we can access both the value of 10 from both the pointers. So let's see how it is done. Printf percentage D, comma, pointer of PA. So we can access the value through pointer PA, and also we can access the same value from pointer P as well. Both of them are referring to the same value now. So let's see the output of the code. So as we can see, we are getting 10 and 10 because both the pointers are accessing to the same value. And we can also change or modify the value of A through the pointers. So if we gonna modify the value of A through one pointer, it will be reflected to the other pointer as well. Like suppose if we increment the value of A through one pointer, it will be reflected to the pointer PB as well. So let's see the output of this. So we are getting 10 and 11. We are getting 10 because we know how the post increment works. First, it's going to access the value, print it, and then it's going to increment the value. So now the pointer PB will be referring to the updated value, that is the new incremented value. That's the reason why the second output, that is the value of PB, is 11. So that's all about the operations that can be performed on the pointers. One type of pointer, that is void pointer. So what is void pointer? Void pointer is nothing but it's a generic pointer, or it is a special type of pointer which can point to the object of any data type. So what's the advantage of using void pointer is, by having a single void pointer, we can point the same pointer variable to the values of different data types. So let us understand this with an example. So we have three variables A, B, and S, and which is where A is of type int and B is of type character and F is of type float. So now let us declare a void pointer. So void asterisk ptr. So that is how we declare a void pointer. Keyword void asterisk followed by the pointer name or the name of the pointer variable. So now let us assign the address of A to our pointer variable. ptr equals to address of A. So now let us print the pointer variable, print percentage %d, comma. So now we just can't dereference the pointer as we used to do before, because the compiler doesn't know the data type of the value for which our pointer is pointing at. So we have to explicitly convert or change the data type of the pointer. So how we gonna do that is, so as we want our pointer to point at A, which is of type integer, that's why we are typecasting the data type of the pointer to int asterisk followed by the pointer variable name. Then same for the uh, variable B. We're gonna store the address of B to the pointer variable printf %c, comma. Now again we have to typecast the data type of the pointer variable to the char, because we want our pointer variable to point at character now. So that's true. ptr. So again same for the variable f. We're going to assign the address of variable f to the pointer variable, and as f is a floating point, we're going to change the format specifier to float and typecast the data type of the pointer to float. And so let us run this code to see the output. So yeah, we have got 10, A and 13.5. So this is what the advantage of using a void pointer. With the help of a single pointer, that is a void pointer, we can point to the different values of different data types. So that's all about the void pointers. In this part of the video, we're going to discuss about pointers to array concept and pointer inside a pointer. So let us see what do we mean by pointers to array. So pointers to array means the pointer variable is used to store the memory address of the first element of the array, and the pointer variable can be used to traverse through all the elements which are present inside the array. So let us understand this with an example given over here. So we have declared a variable int a, or it is an array which is of type integer, and we have initialized 5 values to it, that is 10, 20, 30, 40 and 50. And then we have declared a pointer, that is int asterisk ptr. So this is our pointer variable, and now we can see we have initialized the a, that is the array a to the pointer. In the previous videos we have seen that we used to use the address operator to initialize the pointer, but over here we are not using any address operator. That's because when we say array, the array will have the address of its first element, so there is no need of again mentioning the address operator to initialize the pointer. So as the array, that is in our case it is a, so as the a is having the address of the first element, we are just passing the address of a to the pointer variable. So now the ptr will be pointing to the first value, that is 10. So now when we say printf of asterisk of ptr, our ptr is pointing to the first value, that is 10. So 10 will be printed as our output. So if we run this code, So we can see over here in the terminal, we got 10 as our output. In the next line, we are declaring as PTR equals to PTR plus 3. We are actually incrementing the position of the pointer, but not the values of the pointer of the array. We are actually incrementing the position of the pointer. So when we say PTR is equals to PTR plus 3, the position of the pointer will be moved 3 spaces towards right from its current position. So the current position of the pointer is value 10. So when we say PTR plus 3, it's gonna move 3 position towards right. That is from 20. It's gonna move 20, 30, 40. So the new position of the pointer will be 40. So when we say printf of asterisk of PTR, the new value of the pointer will be printed as 40. Let us see the output of this. So as we can see, we got 40 as our output over here. So in the next line, we are actually decrementing the position. It's similar to incrementation, but we are using decrement operator over here. So when we say PTR minus minus, our current position of the pointer is value 40. So when we say PTR minus minus, it's gonna move backwards by one place. So the new value of the PTR will be 30. So again, when we say or when we print the printf of asterisk of PTR, the new value of the PTR will be printed as 30. Okay, I have not saved it here. So yeah, as we can see over here, we got 30 as our new output. That is, the pointer is pointing at value 30. So in the line 13, we can see we are specifically assigning the address of fourth index value to our pointer. What is the fourth index value in the array? That is 0, 1, 2, 3, 4. That is, we are initializing the address of this value 50 to our pointer variable PTR. So now our pointer variable will have the address of this value 50. So as it is pointing to value 50, so when we dereference this pointer, we should get our output as 50. So yeah, as we can see in the terminal, we got 50 as our output. So this is how, using pointers, we can store the address of the first element of the array. Through that, we can access the all the elements present inside the array. So now let us see about pointer inside a pointer concept. So pointer inside a pointer is nothing but actually it is defined for a situation where we have a pointer variable or one pointer variable, and for that pointer variable we'll be storing the address of another pointer variable, and then we're gonna create another pointer or the second pointer for which we'll be assigning the address of the first pointer. So the second pointer now is called as a double pointer or pointer to pointer. So let us understand this with an example how it is done. So let us declare a variable like int a equals to 20. So the value of a is 20, and we're gonna declare pointer, that is int asterisk of ptr1. So for this we are initializing the address of a, and then we're gonna declare another pointer. So this is called as the double pointer. So we'll be having two asterisk marks followed by the pointer variable name ptr2. So for this we will be assigning the address of the first pointer, that is ptr1. So we can see here the ptr2, that is the double pointer, we are indirectly accessing the value, that is 20 over here. We are indirectly accessing the value 20. So how is it possible? See, so when we dereference the ptr2 or when we dereference this pointer, so we know that dereferencing the pointer means value at that address. So ptr2 is storing the address of ptr1, that in turn is storing the address of variable a. So ptr2. So dereferencing the pointer variable 2 will indirectly lead us to the variable a, that is for value 20. So if we print this percentage d comma, so if we dereference the ptr2, so when we're if we run this code, as we can see, we have got our output as 20. So with the help of double pointer, we are indirectly accessing the value of this a. So that's how pointer to pointers or a double pointer works. So that's all about the pointers to pointer concept.